All right, let's wrap up chapter 7, which has been talking about quadratics, and we're going to work on word problems. And there are two types of word problems that we will be doing. One is going to deal with objects being thrown into the air or dropped from a elevated position. And for that, we're going to need a formula. And this is actually a physics formula that you will see when you do physics. And I will explain exactly what this formula is. And luckily for you, you won't need to memorize this. I will give this to you on quizzes and tests. We do need to know how to use it. All right, H. H is for heights. So HF is our final height. HI is our initial or starting height. Whoops, there's an I in there. I'll rewrite it. T is time, and V is velocity. So we're throwing something into the air or we're dropping something. We need to know the height that it starts, the height that it ends, the time, and the velocity, how fast this object is being thrown or shot out of a cannon. When you look at this equation quickly, you might wonder, where did this negative 16 come from? And that's just the pull of gravity. How strong gravity can pull an object to the Earth's surface. And that's just always the same thing. All right, so that's a little vague. And if you haven't seen it in physics, if you haven't taken physics, I understand. But let's do one. And I'll draw a little diagram. You're standing on a building that is 80 feet tall. And you throw this, let's call it a baseball, and you throw it into the air. So it goes up and it comes down. And eventually it lands on the ground. And we want to know a few things about this scenario. First of all, I will tell you that we know that you can throw at 64 feet per second. That's the velocity of the baseball. So again, you're 80 feet high and you throw this baseball up in the air and it comes down and hits the ground. And there are three things we want to find out. Okay, first, we want to find out the time to its max height. How long is it going to take this baseball to get right there? To the part where it stops going up and it just is about ready to come back down. 2, we want to find out what its max height is. How far above the ground will this baseball be? And 3, how long the time until it hits the ground. So we want to know how long until the top, how long till it hits the ground, and what's the distance from the very top of the ball, the arch, to the ground. All right, those are the three things we're going to find. We're actually going to do them in that order. Well, first, let's take our original equation. The final height equals negative 16 time squared plus velocity times time plus the initial height. Let's substitute in our numbers. What numbers do we know? Well, we know the initial height is 80 feet because we're 80 feet high in the building. And we know that we throw the baseball at 64 feet per second, and it's a plus 64 because we throw it up into the air. All right, and I will fill in the rest of it. All right, so how can we figure out the top of that parabola? Well, and I'm going to draw one here just so we have it for reference. It kind of looks like that, and we're looking for this top part. Well, what would we call this green point? This green point is called the vertex. And hopefully you remember there's an easy way to find the vertex of a parabola. There's at least an easy way to find the x-coordinate, which we used to call h, and that was negative b over 2a. Again, hopefully you remember that from last section. Now we can substitute in some numbers. B would be positive 64, so let's put a negative out in front, and A is negative 16. That's just negative 64 over negative 32, and that divides out to 2. And since we're talking about time, we're saying seconds. So it will take 2 seconds for our baseball to reach the top of its parabola, or its arch. Now we need to find out the height. And how would we do that? Or how did we actually do that in the last section? Once we found the x coordinate, or the letter h, we plug that in. So let's take negative 16 plus 64 plus 80, and we'll substitute in the 2 that we just found. We said it takes 2 seconds to reach its maximum height, and that's like negative 16 times 4 plus 128 plus 80. That's like negative 64 plus 128 plus 80, or 144 feet. Excellent. So we know that in 2 seconds, our baseball will be a total height of 144 feet high. Now the last part is just finding when it hits the ground. And looking back at our equation, what do you think the final height would be when the baseball hits the ground? We know this is the right side of our equation. What's going to go on the left side for our final height? Well, if it's on the ground, the height is just 0. So we have to solve for t, and this is where you get your choice. And now you have 3 choices. You could factor. You could complete the square, obviously I'm abbreviating, or you could use the quadratic equation. It's your choice. I will do this problem all 3 ways. So you get to choose your way, but I will do it all 3. That way you can see we'll get the same answer. All right, so let me factor. I have my equation, and I notice that I can divide everything by a negative 16. And look how easy that equation becomes. If I divide everything by a negative 16, t squared minus 4t minus 5. This factors to t minus 5, t plus 1. T minus 5 equals 0, so t equals 5. T plus 1 equals 0, t equals negative 1. And which of these makes sense or does not make sense? We can't have negative time. We can't go backwards in time. So the ball must hit the ground after 5 seconds. Well, that's all well and good, but you decided that you wanted to complete the square. Well, in order to complete the square, our leading coefficient, A, has to be 1, so you absolutely would have to reduce. What if you completed the square? What would that look like? Well, you started with t squared minus 4t minus 5 equals 0. You know you need to add that 5 to the right side. Now, off to the side, you took negative 4, your b term, divided by 2, that's negative 2. You squared that, that equals 4, so you added a 4 to both sides. The left side factors to t minus 2 squared equals 9. Square root both sides, t minus 2 equals plus minus 3, because that's the square root of 9. Move the 2 to the right, t equals 2 plus minus 3. So my answers again are 5 and negative 1. Look at that. Same exact answers. Doesn't matter that we did it a different way. Negative 1 doesn't make any sense. The ball hits the ground after 5 seconds. All right, but you're a quadratic equation type of person. I get it. That's fine with me. T squared minus 4t minus 5 equals 0. Again, we have to have it equal to 0. We plug in our numbers. Minus a negative 4 is a positive 4. Plus minus negative 4 squared minus 4. A is 1. C is negative 5. All over 2 times a, which is 1. That's 4 plus minus square root 16 plus 20 over 2. That's 4 plus minus square root 36 over 2. That's 4 plus minus 6 over 2. That's 10 over 2, which is 5, or negative 2 over 2, which is negative 1. And again, negative 1 doesn't make sense. Our ball hits the ground in 5 seconds. So that's how we're going to do these problems. And again, it's your choice. Factor, complete the square, quadratic equations. I will warn you that I will not give you all problems that factor. So you will have to be able to do complete the square or quadratic equation for some of these problems. So again, our ball reached the maximum height in 2 seconds. That maximum height was 144 feet, and it hit the ground in 5 seconds. Let's try another one. Example 2. We're going to throw a ball off of a building, and that building is 200 feet high. And the ball will go something like this. And the initial velocity, the upward velocity, is 96 feet per second. And we want to find all of our information. We want to find the highest point, how long it takes to get to the highest point, when it hits the ground. And this time I'm going to talk about something else. When is it going to reach eye level? When is it going to be back at 200 feet? So a few different things to find. Let's get started. We'll start with the same equation. The height is negative 16 times squared plus the velocity. We know that's 96 time plus, and in this case, 200, because that's our initial height. 96 from the velocity, 200 from our initial height. Well, we need to find the vertex, so that's where we use our negative b over 2a. B in this case is 96, so negative 96 over 2 times a, which is negative 16. Negative 96 over negative 32, that's just positive 3. So we know that in 3 seconds, when x is 3, that's when the ball reaches its highest point. In order to find that highest point, we just plug 3 into our height equation. So height equals negative 16 t squared, we said t is 3, plus 96 times t, which is 3, plus 200. Well, that's negative 16 times 9, plus 288, plus 200. And depending on how basic you want me to write this, negative 144 plus 288 plus 200 gives us a maximum height of 344 feet. Awesome. That is quite the throw. (344 feet). All right, so we know that in 3 seconds, our max height is reached. That max height is 344. And let's find our other two things. We want to know when it hits the ground and when it's eye level. Now, luckily, eye level doesn't require any math. Oh man, that's pretty awesome. So again, we're going to think about the idea of a parabola and the fact that it is symmetrical. And if it took 3 seconds to reach the height, or the vertex, the maximum height, how long would it take to reach eye level? Well, think about it. If it takes 3 seconds to get over here, it takes 3 more seconds to get over here, a total of 6 seconds. So it would reach eye level in 6 seconds. And we like when we don't have to do any equations or any real hard math. The last one will require some math. We want to know when this thing hits the ground. So we have our height formula, h equals negative 16 t squared plus 96t plus 200. Now what I'm going to do to try to make this all easier, we know that when it hits the ground, height is 0. I'm sorry if my t's look like pluses, bear with me. Writing on this screen is not the easiest. Now, how can we make this easier? Well, one thing I would do is just go ahead and divide everything by negative 16. Let's just try to make these numbers smaller. So that gives me 0 equals t squared minus 6t minus 12.5. Now we're going to have to solve for t, and we have our 3 choices. So first, we're going to try to factor, and this does not factor, and we don't like trying to factor decimals anyway. So since that doesn't factor, our 2 other choices are complete the square or quadratic equation. And it's up to you which one you do. Again, for this one, I will do it both ways, but essentially for you, you're only going to do one of these 2 ways. So here we go. If you wanted to complete the square, t squared minus 6t minus 12.5 equals 0. You know you need to add the 12.5 to the right. Then we take half of negative 6, which is negative 3, and we square that, and we get positive 9. So we add 9 to both sides. Factor the left, t minus 3 squared, and on the right, 9. Okay, yeah. 21.5. Or, as we know it better, 43 over 2. Square root both sides, so t minus 3 equals plus minus the square root of 43 over the square root of 2. We're not allowed to have square roots in denominators, so I will do that to get square root 86 over regular 2, and add my 3. T equals 3 plus minus square root of 86 over 2. Get that into your calculator. Make sure you put parentheses around this fraction, and we should get 7.64 and negative 1.64. Which one of these answers makes sense? Only the positive answer. We can only be in positive time. We cannot be in negative time. So the ball will hit the ground in 7.64 seconds. If you did the quadratic equation, so we had t squared minus 6t plus 9, I'm sorry, 6t minus 6t, t squared minus 6t minus 12.5 equals 0. Quadratic equation, x equals negative b, which turns into a positive 6, plus minus negative 6 squared minus 4 times a, which is 1, times c, which is negative 12.5, over 2 times a, which is 2. That's 6 plus minus 36 plus 50 over 2. That's 6 plus minus 86 over 2. And that is our same answer, 7.64 or negative 1.64, and only the positive answer makes sense. So again, it does not matter if you complete the square or if you use quadratic equation, as long as you get the right answer. And remember which one in terms of time makes sense, the positive time. In example 3, we're going to look at a different scenario. So you and your friend are standing on a bridge. This is the best bridge I can draw. And the bridge is 500 feet high. One of you drops a rock. I'll say you drop the rock. You drop the rock, but your friend throws the rock down. And they throw it at 40 feet per second down. And the question is, how long is it going to take each rock to hit the ground? So we're going to look for time for you and your friend. All right, well, yours equation, height, negative 16 t squared plus velocity. What do you think velocity, the initial velocity, would be if you dropped it? If you just held the rock and dropped it? Well, your initial velocity would just be 0. Because you're holding it and you just let it go. It has no velocity at first. What do you think your initial height is? Correct. Your initial height is 500 because that's how high you are on the bridge. So let's solve. When our height is 0, because that's when it hits the ground, we get negative 16 t squared plus 500 because 0t just cancels out. And now you would solve this like any equation. We have a t squared, so we're going to move the 500 to the left. We would divide by 16. And I'm just going to use fractions, 500 divided by 16. Or you could use a decimal, 31.25. Either way. But that's t squared. We need the square root. So if we do square root of 500, I think that comes out to be 10 square roots of 5. And the square root of 16 is just 4. That reduces, if you wanted to 5 root 5 over 2. Or we could just do the square root of 31.25. Either way, you should get 5.59 seconds. 5.59 seconds. If you do 5 square roots of 5 divided by 2, or if you just did the square root of 31.25. Not too much math involved on that one, so that was good. So if you drop this rock, it should hit the ground around 5.59 seconds. What about your friend, though? Your friend actually throws the rock down. So the beginning of the equation would be the same, negative 16t squared. The end of the equation would be the same. But what about this middle part? And before I write it down, I'm going to give you one more key. I'm going to try to clue you in on the middle part. Remember that your friend is throwing the rock down towards the ground. So that velocity would actually be negative 40t. Because they're throwing the rock down, it has to be a negative. And hopefully you were thinking that already, that this is a different problem. So far we've been throwing things up into the air. That's why velocity was positive. This time we're throwing it down, so velocity is negative. Well, if you wanted to, let's go ahead and make these numbers smaller. I would again divide everything by negative 16, and I would get t squared plus 2.5t minus 31.25. And again, I'm doing that to to make the numbers as small as possible. Obviously, we need a 1 out in front if we want to complete the square. Now, if you wanted to delete, and I'm just going to write this real quick, if you wanted to try to factor but not have decimals, multiply everything by 4, we could get 4t squared plus 10t minus 125, and you could try to factor that. I'll just tell you that this doesn't factor. So let's just go back to this equation and ask yourself, do you want to complete the square or do the quadratic equation? And with decimals, I'm just going to go straight to quadratic equation. You can complete the square if you want. You'll get the same answer if you follow the steps. But I'm just going straight to quadratic. Negative b plus minus b squared minus 4 times a times c all over 2a, which is 1. That's negative 2.5 plus minus, I almost forgot my plus minus in there. 2.5 squared is 6.25, and 4 times 31.25 is plus 125 all over 2. So that's negative 2.5 plus minus square root of 131.25 all over 2. And if we crank that out in our calculator, we get 2 times, of course, because we have plus or minus. You either get 4.48 or negative 6.98, and only one of these makes sense. 4.48. So your friend throwing the rock actually doesn't get the rock down there much faster, about a second faster. We're 5.59 for us, 4.48 for your friend. And those are the 3 examples for applying parabolas. And there's a lot of different applications, but I want to keep it pretty limited. We're either going to throw rocks up in the air or throw things down in the air, try to figure out their max height if we throw them up, how long it takes to get to the max height if we throw them up, or if we drop them or throw them down, how long it will take them to get to the ground.